This item is part 1 of test item analysis, and we will describe the different steps that you will be taking in an item analysis. And so first, let's talk about what an item analysis is. It's the process by which exams are examined critically. And then the purpose of it is to determine whether the items are functioning according to expectation and to identify structural flaws and improve the item quality. Now, this is just showing you a sample item analysis that one might get for a test. Usually there is software that will be used and give out these different results, and we will take a look at those in part 2. Now, first we're going to look at the validity of a test, and that is simply referring to whether or not the test measures what it claims to measure. On a test with high validity, the items will be closely linked to the test intended focus. So in other words, if a test has poor validity, then it does not measure the course-related content and competencies. When this is the case, there's no justification for using the test results for their intended purpose. Now, there are multiple types of content validity. First is content validity. This addresses the match between test questions and the content or subject area they're intended to assess. Next is criterion-related validity, which looks at the relationship between a test score and an outcome. Predictive validity refers to the power or usefulness of test scores to predict some future performance. An example of this would be your GRE scores to predict how well you would do in a graduate program, or GPAs in high school to predict nursing school performance. Face validity is probably the least valid of all, something like content validity, but really it doesn't have to be viewed by an expert. Someone just looks at the test and on the face of it, it seems to address the constructs that it's supposed to. Now, reliability of a test is the degree to which a test produces stable and consistent results. It indicates the consistency or stability of a test performance, and it's one of the most important considerations when selecting test and other assessment tools. A test must be constructed so that examiners can administer it with minimal errors and interpret the performance of students with confidence. Now, there are sources of error that can affect the reliability of a test. It could be noise distractions, poor lighting, uncomfortable room temperature, hunger, fatigue, illness, difficulty in understanding test instructions, difficulty in understanding or interpreting language used, ambiguously worded questions, biased questions, different interpretations of the wording of test questions, unclear test directions, insensitivity to a student's culture, language, preferences, or other characteristics. The measure of reliability. Well, reliability is measured on a scale of 0 to 1. A reliability coefficient of 1 would represent 100% correspondence between two tests or measures. A reliability on a test of 0.7 to 0.8 is acceptable for these classroom tests, but two main factors that you may not be able to control can lower this. First, an insufficient number of test questions. Second, an insufficient number of test takers. Next, the difficulty index. Well, that's simply the percentage of students taking the test who answered the item correctly. The larger the percentage of getting an item difficult right, the easier the item. The higher the difficulty index, then the easier the item is understood. Now, you can compute that by hand, but it's usually calculated for you when you're using test software. So what has to do with the difficulty index? Well, the proportion for the item is usually denoted as a P, and we call it the P-value, or the difficulty index. If 85% of the examinees, okay, got an item correct, then we say that the p-value is 0.85. If 50% got it correct, then it would be 0.50. Now, a p of 50% or less means that that item is very difficult. A p of 51 to 69, that means it's difficult. 70 to 80, that means it's average difficulty. And if 81 to 100% got it correct, and that is what the p-value is, then it is easy. Now, the discrimination index. This refers to the way a test item differentiates students who know the content from those who do not. Discrimination is measured by the point biserial correlation. It's also called the point biserial index, or just the PBI, and it's used to find out if the right people are getting the items right and how much of a predictive power it has. A question that discriminates well has a highly positive PBI for the correct answer and negative PBIs for the distractors. Now, here are some examples of ranges for the PBI. It ranges from a -1 to a +1, but if we're seeing 0.3 and above, well, that's a good discrimination. 0.1 to 0.3, that's fair. If we see a PBI equal to 0, then there's no discrimination. All students got the item right. If we have negative, then that means it's a poor item. The item was flawed or miskeyed if the correct answer is negative PBI. Now, we next and last will really look at our distractors, and these are the incorrect alternatives in a multiple choice item. One way to study responses to distractors is really with the frequency table, and that tells you the number and or percent of students that got an answer correct. Now, the acceptable range is that each distractor should be selected by at least a few students. The ideal is that all the distractors should be selected equally. I will tell you that never happens. Now, factors contributing to learners selecting incorrect responses. Well, the question could be ambiguous. The question has no or more than one correct answer. The content was not adequately taught. Students were unaware the content was important. The question contained cues that misdirected students. Students missed an essential element of the question. Students were confused by a question's logic. For example, in the STEM, you may have double negatives. Or students chose not to study the content. Now, after the exam, faculty get together and they look at item modification. There are some options for those. So you can change the correct answer. You do this if it was miskeyed. You accidentally put another response as being correct. You can add an additional correct answer, but only do this if for real there is a second correct answer. Change all responses to the correct answer if the item just tested poorly, and then rerun after you make any modifications the test through the software so you get new statistics. Now, what psychometricians will tell you is that you should eliminate a question from the exam if it tested poorly. I will tell you then what that means. No points are given. People that got it correct don't get any points. People that got it wrong don't get any points. However, it's not usually suggested that you do this because it lowers the grade for all students, including those who answer correctly. So, for example, if you had a test of 50 questions and 47, you end up with 47 questions because you decide you're throwing out 3 questions because they didn't test well. Well, that means that instead of the final grade being based on 50 questions, it's now based on 47. Can you see how this would lower the grade for everyone? Now, sometimes faculty will tell you, my students have a bell curve. On a test made by a teacher-made test in a classroom, you will not ever have a bell curve. So I just want to mention this because it is a myth that I really hear propagated all the time. And so the only time you see a bell curve is when you have a standard test, such as an IQ test, or if you have an SAT test or something like that. So in other words, on IQ, 68% of us really fall into the average performer. Those of you in this graduate program, though, probably fall here in the high performer, and those of you that are in Mensa fall more like here with your IQ. Now, let's look at a skewed curve, because that's what you're going to find in teacher-made tests. And you will see histograms, they call them, showing your student results. Now, positively skewed and negatively skewed really refers to where the tail is. So this is positively skewed and this is negatively skewed. A teacher-made test will be negatively skewed. This is where the peak of the results will fall, the high is like 100, and this is where those that didn't do as well in the test will fall. Now, negatively skewed, this is an example of a test, for instance. Here's the score of 100. Here's where most of your students fell, a little bit above 80, and then you can see we come down. Now, if we begin this curve here and go up, it's negatively skewed. Now, there are certain terms that we're going to find in item analysis, such as N for the number of items on the test, a raw score, which is the actual score. So if you have 20 questions and people got 18 correct, then their raw score is 18. We haven't yet based it on 100%. The mean score is the average score. The standard deviation is the range above and below the average score. The more the score are spread out, then the higher the standard deviation. The range is the highest score minus the lowest score, and it's a measure of variability. Now next, we're going to be, in part 2, looking at a few test results and analyzing them.